Hi, sir.
Hello, Amy. How are you doing?
I'm good, thank you. How are you? Okay, yeah,
All right. Now,
that would
today
work.
we'll do some part of statistics. You actually shared with me some of your course material, and based on that, I prepared a lesson for you. So I thought today we'll discuss about mean, quartiles, cumulative frequency, and all these things, right? So that will give you a good foundation of how to work with data. So what I did was that I'll actually split this class into two parts. In part A, we'll discuss about how do we find mean and quartiles when discrete data is given to us. And in the next half, we'll discuss how do we find the same things when the continuous data is given to us. So that'll give you a very good overview on this particular topic. Okay.
Mhm.
So let me share with you the screen and then we'll work from there.
All right.
Great. So we'll first work with the raw data and see how do we work with the raw data to find medians, the first quartile, third quartile, interquartile, and in the next video, actually, we'll make a box and whisker diagram and go further on statistics. Okay.
All right.
Today, in this video, we'll talk about what is median, what are quartiles, what is percentile, and what are outliers, and how do we calculate them. So we'll discuss how do we estimate median. Now it is very important to understand that in this part of statistics, we are only estimating. We are not providing accurate results. There are no formulas to give you accurate results, right? It is the best
Right.
estimate which we can make. Is that clear to you?
Yeah.
So we'll estimate median, we'll estimate first quartile, we'll estimate third quartile. Now, median, as you know, is also called the second quartile, right? So these are the three major means, you can say, which will be dividing the whole data into four equal parts, right? So the
Right.
median divides into two equal parts, and then the left and which we call the lower half is divided further by the first quartile equally, and the upper half is divided further by the third quartile. So we get three equal parts. When we say equal parts, number of data points are same in each part. Their values will of course be
All right.
different, right?
Mm-hmm.
Then we will see what is interquartile range. Interquartile range is defined something in between Q3 to Q1. So difference of these two values will give us the interquartile range. Since all these values are
Mm-hmm.
estimated values, so that is also an estimate. Based on interquartile range, we can actually find the outliers. Outliers really means that they do not really represent the major part of data, right? They are like kind of outside the data in which we are focusing on. So we have a mathematical
Mm-hmm.
formula which can help us find whether this data element is an outlier or not. So we'll also look into that. We'll also see how do we work with percentiles. So we'll take up an example to find out how many elements are there in this given data set which are above 90 percentile. Now, coming back to median, median could be referred to as 50th percentile. It is the middle value. First
Mm-hmm.
quartile can be considered as 25th percentile. Third quartile is the 75th percentile. So when we are calculating medians and quartiles, we are actually calculating percentile. Okay, so they're all very related terms. We'll begin with
Mm-hmm.
median to start with, since you know all those values. I have the center values, the medians for different regions as we had just talked about. So median can be found using a formula. That is, it is you have to find the number of elements. So first part of finding the median is arrange your data in ascending order, increasing order. First part. Once you arrange your data in increasing order, we want to see which value is right in the center. Now, if you have
Right.
odd number of data elements, then you will get exactly one element in the center, correct? So
Right.
you get an exact answer, which will be part of the data, correct? If I take value like 1, 2, 3, 4, 5, then 3 is right in the middle, which is the median, correct? Two on the right side, two on the left side. You
Yeah.
get the idea. So if you have odd number of data elements, in that case, median is, you can, like I took example of 1, 2, 3, 4, 5. 5 plus 1 is 6. 6 divided by 2 is 3. Third element, so n plus 1 divided by 2, that gives you the term number. Value of that term number is the median. So we could write this as median equals to d. D we are calling a data function. We'll use this as a function, right?
Um,
So I'll introduce you the set of elements, and we'll name this as our data elements d. Okay. So
okay.
the value of the element term number n plus 1 divided by 2 will give us the median, right? So that happens when
Right.
you have
Mhm.
odd number of elements in the data set. However, if you have even number of elements, that is, if I have numbers like 1, 2, 3, 4, 5, 6, in that case, you'll notice that 3 and 4 both are in the middle, two on the right, two on the left. Then what is the median? Median is average of these two values. So you have to add 3 and 4, then divide by 2, get 3.5 as the median. So accordingly, we have a formula here. Then median will be the term number n by 2 plus the next term, those values divided by 2 will give you the median. So that becomes a general formula to find the median when we are working with the data elements. Now, I love fish, and not to eat them, but to wash them, right? So, yeah, I'm vegetarian otherwise. So I've taken two examples based on the fish size. So we have one which says quartiles for odd number of data elements, and the second one relates to quartiles of even number of data elements, right? So that gives you overall how do we work with any data set where odd or even, these are the two possibilities, correct? So we'll have very simple examples mainly to understand the concept. So here we have the following data shows length of 15 trouts rounded to nearest centimeters. We just rounded the data also, avoiding decimals in this case. So 32, 33, 24 randomly, like you are just picking up one by one, measuring them and putting them in the bucket, and you find these to be the lengths of those trout, fish. Now, this is
Right.
called the raw data. You just picked, measured, and kept a record of it. And then you got that 15 of them were of this size. We are given this data, and we need to find from this data all these things. That is median, first quartile, third quartile, and based on this, we'll have more questions. Now, in the second example, I've taken again a very similar case. The following data shows length of 16 salmon, right? So 16 salmon makes it even number. So they're slightly longer. So I just took some numbers here to find their length in centimeters, rounded to centimeters. But this time I arranged them in a particular order. Will not take that extra time to arrange, okay?
Oh, okay.
So these are the two examples which we are going to consider. So let's begin with the very first one. So which is the following data shows length of 15 trouts rounded to nearest centimeter. So that is the data given to us. Now, we need to arrange this in a particular order. That is the first thing which we have to do. Let me summarize what we learned earlier. We learned that median, how do we find it? First, we need to arrange the data in increasing order. When we will arrange them in increasing order, we'll call it a data set, and I represent this as a function, d of n. So n will give you term number, right? So d of n will give you value of that term number. So that is the nomenclature which I am going to use. Median m is the middle value. Let n be the total number of data elements, then the value of median will be the value at the center point, which will be n plus 1 over 2 if n is odd. If n is even,
Yeah.
in that case, it is average of the n by 2 and n by 2 plus 1, the next consecutive terms, correct? And the logic is, if you have odd number of elements, definitely you have one element right in the middle, and that becomes the median. So median in this case is 7, very clearly. But if you have a sample like this, which is even number of data elements, in that case, there are two numbers which could be considered in the middle. So the average of that will be the median. This is a very important point to understand. Every time n plus 1 divided by 2 will give us directly the term number if we have odd number of elements. However, that term and next term will be considered, and average of those two will give us the median when we are considering even number of terms. Is that clear?
Yeah.
Okay. So again, all the same things which we have to consider, but I think it is very important to understand this concept. Now let's go. How do we solve it? So we are given these elements. We have to arrange them in increasing order. So 18 seems to be the lowest, which comes next, and then all the terms have been increased, have been put in increasing order. So we now have an arranged set, and this set I'm calling as D of n. So this is my first term, second term, third term, fourth, fifth, and that'll be my 15th term. So I will say, what is D of 15 for me? D of 15 is equal to 38, correct? That is the nomenclature. If I say D of 5, it means fifth term, 1, 2, 3, 4, 5. It will be equal to 30. Do you understand? So the fifth term value is given by D of n. It's a function notation. It helps to communicate. Many books do not follow this kind of function notation. However, without this, I find it difficult to explain. So we will use this, okay? Right. Now, so I'm going to deviate in many aspects from most of the books. So I will also recommend you that once you learn from me, just confirm with your teacher if that works good with him. Otherwise, you may have to use the formulas which are being used at your school. Is that okay?
Yeah.
Fine. We'll get similar results though, but our approach will be slightly different. Okay. So now, let's get back to the solution. We know that the total elements are 15, which fortunately for us is an odd number, and therefore 15 plus 1, which is 16, divided by 2, will give us the term number, where we will find the median value, correct? So median is a value for that term which is in the center. So 15 plus 1 is 2. 15 plus 1 divided by 2 is 8. So we'll look at the eighth term. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. Eighth term for us is 33. And therefore, the median is 33. You get the idea?
Yeah, makes sense.
That is how we'll find median when odd number of terms are given to us. Now look here. Once we have found the median, we need to now find first quartile and the second quartile. First quartile is 1/4 of the data. So that means this part of the lower half, we are going to find the middle value of this. You get the idea? So the middle value of this
is...
So
you don't include the median.
Yeah, you don't include that. Yeah, that is out now, right? Lower to this and upper to this. Is that clear to you? So the middle values of this will be what? So 3, leave 1, 2, 3, and then you have two terms in the center. Or what you can also do here is find the 25th percentile to find Q1 and 75th percentile to find Q3. So in that case, you don't have to see whether you have to ignore it or not to ignore it. You get my idea?
Oh, okay, yeah.
So that we are going to use this method now. Is it clear to you?
So if you do 0.25 times 15.
N plus 1. So we used n plus 1. Many books will use n. Okay, many books will use just n. But with n, you do not get the middle value, as you have seen very clearly. It is n plus 1 divided by 2. So that is again a difference between many books which use n, and what we are going to use here is n plus 1, because that gives you the middle value, not n. Is that clear?
Oh, right. Okay.
Because 15 is, if I divide 15 by 2, I do not get 8. I get 7.5. If I get 7.5, then I have to take average of these two values. Do you understand? Average of 32 and 33, which will be 32.5. In that case, the answer will be 32.5 as a median. Now, the point is, both are estimates. Both are estimates. And therefore, we should not really fight over it, right? It's an estimate.
Oh,
You get my
okay.
point?
Yeah.
So whether I write 32.5 or 33, it's not that
It's an
critical.
estimate.
You get my point. However,
Right.
if
Yeah.
we adopt a formula and a method to follow, we can justify our numbers.
Oh, right.
That is more
Okay.
important.
Yeah.
Method is very important, correct? We are not doing it at random. Okay.
Mhm.
So, so we'll actually look for the middle value, which you have seen very clearly is n plus 1 divided by 2 term number. Is that okay? The value of that term.
Yeah.
Right. Now let's move forward to find the quartiles. Okay. So what I did was, as I was trying to explain you, I have actually used both the methods. So to find the first quartile, I'm going to use two methods here. So the first method here is to find the quartile means we are looking into the left half. Is that clear to you? We want to find the middle term of this left half. So middle of the lower half. This is called lower half of the data. From the median left is the lower half and right portion is the upper half
Upper.
of the data. So what is the middle value of the lower half? You can see very clearly there are 7 terms and therefore
Yeah.
29 is the middle value, correct? So
Yeah.
that becomes Q1. So Q1 is 29, correct? Easy.
Oh, right. Yeah.
Q3 is 75th percentile or the median of the upper half. So the upper half starts from this, as I told you earlier, and the middle value is 36. Therefore, Q3 is 36. Is that clear to you?
Mhm.
So
Yeah.
without any formula also, we get the same results. However, if you have
Right.
1,000 numbers, you are not going to, go and count and do all that. I mean, it becomes easier to work with numbers, right? And the function which I said. Okay, so this is our first method, very clear. If the data set is about like 20, 30 elements, this is very easy to work with. Just list the elements in increasing order and find the center values. That is your answer. Perfect. Now,
Yeah.
alternate method is, since the first quartile is the 25th percentile, so let's understand percentile also, since that is a part of curriculum, right? 25th percentile means n plus 1 divided by 4 will give us 25th quarter, correct? Quarter of the whole
Yeah.
elements, right? Number of. So in our case, 15 plus 1 is 16 divided by 4 is 4. Fourth term. So which is the fourth term? 1, 2, 3, 4. Do you see that? 29 is the fourth term. So the formula works, and this is the right formula. You get my point. I can say it
Right.
in writing. This is the right formula. It should be n plus 1 and not n.
All right. Okay. So even if it was an even set of numbers, you would do n plus 1 over
And the next
4.
term. And the next term. Correct. Because we have to find the average.
Wow.
You get the. So that is why I've
Right.
taken even also, right? So we got the right answer. You understand how the formula works
Yeah.
and how the data works. Simple example. Now,
Yeah.
let's adopt this alternate method to find Q3 also, the third quartile. Now, in that case, we are looking for 75th percentile. 75 means 3 over 4, right? 3 over 4 means
Yeah.
0.75. So 3 over 4 times n plus 1, correct? And that gives you 12. So 12th
Oh,
element,
done.
if you count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you see that? 36, which is your answer. Or you could do middle value of the upper half, which we saw earlier, 36. That is our answer. The value of the 12th element is the third quartile. Is that
Right.
concept clear to you?
Yeah. Is
Most important. Is that clear? Now,
using the
Amy,
formula and n plus 1.
yeah. So you could do with formula, you could do with visualizing it, dividing the data into half. Remember, as you pointed out very correctly, when we say lower half, we do not include the median, right? Upper half, we do
Yeah.
not include the median, correct?
So I
So
think I'm just going to, like you did, highlight it so that I know that's not included. Because when
not
you're
in,
in the exam condition, it's so easy to accidentally include it as one of
yes,
the elements and then work out the formula and then get it wrong. So yeah, you can't afford for that.
yes. Now here's a question for you, Amy. Can you please read the question and answer?
Yeah. So how many fish will there be in the 75th percentile or above?
Yes.
75th percentile.
This
So
is
in
your
the
data. 75th percentile is 36 for us. Let me erase all of it.
yeah,
So that is
so it says
75th.
or above.
Yes.
So
So
do you
look at the
just,
data.
yeah, there's 36, 36, and 38, which is after.
So how many fish will be in
What?
75th percentile or above? Now, very critical question now, because these two values are same.
Oh, yeah,
The length of the fish of 75th percentile is 36, correct? Since
yeah.
we are including 75th percentile, means we are including the length of 36 centimeters. And therefore, the answer should be all this.
So 1, 2, 3, 4. Would you say 5 fish?
Yes,
Oh,
5.
right.
I understand that 75th is this number, which is coming later than
I
the
was gonna say,
before it. However,
yeah.
the value is 36.
Oh,
How many fish will be in 75th percentile or above? Means 75th percentile means 36. So this is also 36. Why am I going to ignore it? I will not. I will include it.
oh.
Therefore, I will have
So
five
yeah.
elements in this case. You get this point?
Oh, yeah, that's a key point. Oh my God. Because I wasn't gonna, because like you said, because you said 75th, I'm gonna be thinking that's the 36. So everything from that point onwards, you're not gonna look back even if it was the same number, but you shouldn't. You should look back if it is the same value.
But
Oh,
caution,
that's important.
caution is check with your teacher. Caution. Give the same example. Check with your teacher.
Why? Is there two answers? How can that be?
No, globally,
Oh,
see, I am in Canada, you are in UK. We are following very
mm,
different standards, and many teachers do have, I mean, many books follow different standards. They will say, well, for
right.
this, they will say answer is 4. You have to be clear about. I have purposely taken examples which are contradictory. You get my point?
Oh, yeah.
Check with your teacher. Very simple.
Okay. Yeah.
Okay.
Yeah. I will.
You should, and give the same example. Otherwise, if I make this number
Yeah.
35, then the ambiguity is not there.
Right.
So on
Yeah.
purpose, I've
So I
made
will.
36 to understand the concepts. I haven't found any book which will give you this example, because they work with very simple
Oh,
numbers and no, I mean, you understand, not with concepts.
yeah.
They give you
All
very
right.
straightforward example. No, but no, this is your test question. Okay. Next point.
Okay.
Now we'll talk about interquartile range and the outliers. So we have already found what is Q1, what is Q2, and Q3. Q2 is also called the median. Q1 is the first quartile. Q3 is the third quartile. We'll talk about interquartile range. Now, range definitely means in between. So interquartile range is the numbers in between Q3 and Q1. Values calculated were 36 and 29, and 36 minus 29 is 7. And therefore, interquartile range is 7. Clear? That's the formula.
Yep.
Now, other term which we need to understand is outliers. Outlier is extreme value which lies beyond the general pattern of data. That is what we say. So if the data is kind of like this and some values here, that could be an outlier. Do you understand? That is what we're trying to say.
Mhm.
Or let's say some data is here, which is far away from the actual set of data, right? Exceptional cases, that could be an outlier. But how do we mathematically figure out whether this is an outlier or not? That is what we are going to discuss. Okay.
Right.
So outliers could be on the lower end or on the higher end. So they could be on lower or higher end, as I've shown you, lower end or on higher end. They are defined in terms of quartile range IQR. So I'm using IQR as interquartile range. Okay. So we'll calculate outliers on the lower end, which should be lower to Q1, correct? So basically, if we have Q1 here and Q3 here, then outlier on the left side of Q1 will be less than Q1, correct?
Yeah.
So we have a formula. value less than Q1 minus K times interquartile range, Q3 minus Q1, which is 7 for us. Is that clear to you? The value of K by default is 1.5. So 1.5 times the interquartile range. If it is away 1.5 times interquartile range from the major set of data, then it is an outlier. Do you get the idea?
Wait, where did you get 1.5 from?
That we have taken in general. It could be a different value, but normally it is 1.5 times, right? So if it is, we have Q1 here, Q2 here, Q3 there, highest data value, right? And the lowest data value. In that case, your lowest data value could be an outlier if difference between these three, if if it is far beyond this formula, Q1 minus K times, in this case 1.5 times 7, because 7 is our interquartile range, right? And Q1 we calculated as 29. So 29 minus this. So it is that much on the left side of Q1. Then we'll consider all those points to be an outlier on the lower end.
All right. Yeah.
Similarly, the outlier on the upper end will be Q3 plus that. So beyond this, do you understand? If this value, this distance here, the difference is more than 1.5 times 7, which is our interquartile range,
it's an outlier.
It's an outlier. So we have used the values which we calculated. 29 was Q1 minus 1.5 times 7, which gives you 18.5. Now clearly, 18 is lesser than 18.5. And therefore, that is an outlier. Do you understand? Up to 18.5, we accepted the data. But beyond that, we say it is outside. So the lowest point in this case, which is 18, is an outlier. 29 minus 1.5 times 7 will give you 18.5. So we'll accept all the values from 18.5 and greater. Anything less than 18.5 will be an outlier. Similarly, let's figure out on the upper end. Q3 plus K times interquartile range. So Q3 we calculated as 36. I did a mistake here. It should have been 36. So you recalculate. 36 into 1.5 times 7 is how much? 36 plus 1.5 times 7, 46.5. Okay. So this is okay. So the maximum value 46.5. So here, this is well within. So there is no outlier on the right-hand side of this particular data set. Is that clear to you? There's only one outlier, and that is 18. Emmy, so far, is everything clear to you?
Yeah, so just to ask again quickly, with the K, did you say it's always 1.5?
Most of the time.
In any question I do.
If no value is given to you, use this as the default value.
All right, okay. Other than that, everything, it's all clear.
Yeah, that's fine. That's fine. So if they give you some value, let's say they say 1.75, then you use 1.75. If they say 1.2, you have to use 1.2. But if they do not give you any value in the test, use 1.5.
Right, okay. Yeah.
Okay. Now let's take the case when we have even number of data elements. So even number of data elements, we're going to find average of the two values, and then we'll get our answer for median, right? And also for the quartiles. So we'll get a lot of decimal numbers. And these numbers will not be part of the data given to us because these are the values calculated as average between the two given values, correct?
Okay. Right, yeah.
So now, can you please read this question?
The following data shows the length of 16 salmon rounded to the nearest centimeters. 61, 62. Should I read out or not?
Okay.
Yeah. 61, 62, 63, 63, 64, 64, 65, 65, 66, 67, 67, 68, 68, 69, 70, 75.
They are put in order. I'll call this as my
Oh, yeah.
function, a data set, and I'll give it a name. I'll give it a name as d of n. So that really means nth value. Let's say this 1, 2, 3, 4th. The fourth value is 63. D of 4 is 63.
Okay.
That is what we
Yeah.
mean by representing this as a function, right? Okay. Now, again, you know all the terms, so we'll quickly find what is the median. Median really means 50th percentile. You could use the formula, which is n plus 1 divided by 2. Now, when you do that, you get 8.5, right? So
Yeah.
now see the beauty. I'm actually not using that formula which we discussed earlier because we now understand with n plus 1 divided by 2, if you get a decimal value, which is 8.5 in this particular case, it clearly means we're looking into two terms which is between 8th and ninth. You get the idea.
Right. Yeah.
So we'll just go to 8th term and the ninth term and find the average of these two. So it is the
Oh.
average of
Yeah.
D8 and D9. So whenever you get a decimal value, right, straight away, go to the two values on the sides
Okay. Yeah.
and then find the average. Now, even if you would have got 8.25, even then the estimate will be D8 plus D9 divided by 2. You get my point?
Oh, okay.
Any
So
decimal
any
value,
number between 8 and
any
9.
decimal value,
Yeah. Okay.
don't round it up.
Yeah.
I'm saying don't round up.
Okay.
Some books will do round up.
Yeah. I was gonna
No,
ask, but that's why, because I've seen it. Okay.
no. It is the middle value. It has to be a decimal value which is not the part of data. Again, check with your teacher.
Okay.
As far as I'm concerned, no. Don't round up.
Right.
Okay.
Okay.
So as I was saying, there are a lot of ambiguities, right? I'm pointing out some which are like obvious, okay?
Yeah.
Right. So when we find a value, we get 65.5. Now 65.5 is now a value which is being introduced here right in the center. Do you see that? Therefore, the data has been now divided into two parts equally. That becomes your lower half and that becomes your upper half. Do you see that? You don't have to exclude any data element, which we did in the earlier case.
Oh. Right. Because the median is that decimal. That's the one that's being like you when you put that line. That's the one that's already included. So you have to include those terms. Oh.
Got the idea?
Yeah. Okay. I was. Yeah.
First
Makes
quartile
sense.
means the lower half center. Obviously, the lower half center is again even number of elements in between these two, right? And the third
Right.
quartile
Yeah.
between these two. So from the data, easily using our first method, you can find the answer. Otherwise, use the calculation. Calculation is first quartile is the 25th percentile. N plus 1 divided by 4 will give you the number. The number is 4.25. Do you see 0.25?
So it has to. Yeah. So
You
it has
have
to be between
find
4 and 5.
average value between 4 and 5. This is a typing error because I do
Right.
cut and paste.
Oh.
I do cut and paste. I copy this and then just change some values. So,
Oh. It is the same method though, so it makes sense. Yeah.
it's the same method. 4 and 5 is these two values. So I just find average of 60 and 64 and get you the answer. Now, don't do that. 4.25 is closer to 63 and therefore 63 is your answer. No, it is not. Imagine if you would have selected one of these as your median, then your data on the left and right is distorted.
Right. Yeah.
You
That
defy
makes sense.
the quarters. I mean the whole concept. So therefore,
Yeah.
we do not believe in rounding up. No, it makes no sense.
Okay.
It's contradictory.
Yeah.
People follow
Yeah.
easy methods. I don't know why. They're wrong. Now, third
They just
quartile,
want it to be easy.
75th percentile. Okay, because I'm telling you, globally this is not followed. I've seen in your book, but not being followed anywhere else. Let's be very precise on this.
Wait, you've seen it in my book?
Yes.
What, rounding up?
Yes. The example which you shared with me. That's why I asked for your sample examples.
But then what do I do though, if that's the answer?
You do this and check with your teacher. This is what you do. You check with your teacher.
But would I get the same answer though?
No, I can't teach you wrong thing. You have to check with your teacher. Just discuss with your teacher.
Okay, no, because in the book, yeah, that's the book that we're using. But as long as I get the same answer, I don't care what like method I use.
No, you won't get same answer. Because if you round it up, you won't get the same answer.
What? I know, that's what I was thinking. I was thinking, is there a way we could just get the same answer? Oh no.
Now, another alternative is use a different book from your, library and just check.
We don't have one. So that's the one that the teacher uses.
Okay,
The
discuss with your
teacher
teacher.
just be like, this is what's in the book, so you have to follow the book.
So discuss with your teacher. Okay,
Okay.
fine.
Yeah.
Now let's be. If this is not making sense to you, then you tell me.
No. This is clear. So I want this to be the method that I want to follow because it makes sense.
Adopt it, right? So 75th percentile means 3/4 of n plus 1. When you do 3/4 of n plus 1, you get a number which is 12.75. I'm not rounding up. I'm taking up 12th and 13th term and finding their average. It is 68. I am not rounding up. I'm finding the center value. It makes sense. That is the definition of quartiles. They are the middle value of the lower half and the middle value of the upper half. If you go with the definition, this is what you should be doing. Got it?
But this makes sense. Why would they do that? Why would they do that?
Yeah,
why would they round up when they feel like it?
So now you got the concept and the base you can discuss with your teacher. That is what I'm trying to tell you, right? So we found Q1, we have found Q2 and Q3. Interquartile range is difference between Q3 and Q1, and that is 4.5 in our case. Is that clear to you?
Yeah.
See, now, once you understood the concept, how easy the question is, within no time, you can actually find all the quartiles, right? And the interquartile range. Now, let's look into the outliers for this case. We are using 1.5 as the value of K, okay? So we look into something on the left side of Q1, which means Q1 minus 1.5 times Q interquartile range. So Q1 being 63.5 minus 1.54 will give you a value of 56.75. The data is more than that. Therefore, in the lower side, we do not have any outlier for this particular example. On the other hand, outliers on the upper end, Q3 plus K times Q3 minus Q1 gives you a value. See, I'm using a default value of K as 1.5, clearly mentioned there. Greater than will be 68 plus 1.5 times 4.5, and that gives you 74.75. Now, if you check, 75 is an outlier since this value is higher than 74.75. Correct?
Yeah.
So we have an outlier, which is 75 centimeters. So fish whose length was 75 centimeters is an outlier. Is that clear to you?
Yeah.
Perfect. Now let's look into the percentile. We had been working with percentiles so far. Median is 50th percentile, Q1 is 25th percentile, Q3 is 75th percentile. Now let's see an example which says greater than 90th percentile. So I'm taking the same examples. How many fish will be above, means not including, 90th percentile? So clearly, to find the 90th percentile, I'll multiply n plus 1 by 0.9. So when I do that, I get 0.9 times 16, which is 14.4. So value for 14.4 means we have total 15 trouts, correct? So one less than 14.4 is not 15, correct? 14.4 is not 15. So it is in between 38 and 36. 14.4 value will be in between these two, right?
The 14,
so when we add these two, we get a value 37. Any value above 37 is above 90th percentile. So we have one example, which is 38, correct? So in this case, 38 centimeters is above 90th percentile. Is that clear to you?
Yeah.
Very important. You know, always you won't get this because I could have had 36 here also. In that case, there is no element above 90th percentile.
Right.
You get my point?
We calculated to be 37. Yeah, makes sense.
Yeah, in this case, because that was 38, and when we found the average,
we could have
lower, and definitely 38 is more than 37. So when the question says above, it is not including 90th percentile. You see the difference in what we had taken earlier. 75th
Yeah.
included, right? This time 90th excluded. Okay, now. So that was our first example. We are doing the same thing for the second example. 90th percentile multiplying by n plus 1 gives us D 15.3. 15.3 means you're looking to average value of 15th and 16th element. And then when you do the average, you get 72.5. There's only one number, 75, which is above this number. And therefore, only one fish with the length of 75 centimeter is above 90th percentile. Is that clear to you?
Yeah.
Fine. So in
Makes
our
sense.
calculations, we always took a value n plus 1, not n, when we divided by or when we multiplied by 0.25, 0.5, and 0.75. And using percentile, the percentile value, right? If the term number is a decimal, when you divide by, then average value of the adjacent values is considered, not rounding up. This is what I want to conclude with. Is that clear to you?
All right. Yeah.
Right. So with this, we come to an end of our how do we work with raw data, right? So this is discrete data where we have found the medians, the quartiles, outliers, and calculated percentile and answered many similar questions. I hope all the concepts are absolutely clear. So, Amy,
Yes.
can you
Yeah.
please summarize what we have learned today?
Yes. So I haven't even read my book yet, so I don't know about what my book requires. But what you've said today, all the concepts, it has to be the way to follow, because otherwise it doesn't make sense. Like just everything, like you said. So we have to do it this way by, like you said, when you've got a set of data, you do, whenever you do finding the median, the lower quartile, the upper quartile, you have to do n plus 1 of that, and then divide by 2, divide by 4, depending on what we're trying to find. So not n, it has to be n plus 1.
First step is to arrange the data in increasing order. That is the
So,
basic. Okay.
yeah.
And then you do all that, what you're saying. Yeah,
Okay.
continue, please.
Oh yeah, so that's the most important thing, because yeah, if the data is not in the right order, when you calculate the fifth term, and if it's out of order, then it's all going to be incorrect. So yeah, sorry about that. Yeah, that's the first point. And then after that, when we were finding the median, so depending on the number of elements there are in that data set, so whether it's odd or even, the same formula applies. This is when we were at school and it got really confusing. He was like, when it's even, you do like n over 2, but then when it's odd, you do n plus 1. So like the best thing is, whether it's odd or even, you do n plus 1, yeah, over 2.
Yes.
And when it's even, you would get a decimal term. That's fine, because that would be the term in between two whole numbers which are in that data set.
Perfect. Yes.
So yeah, so whether it's 4.5, whether it's 4.25, 4.75, that term is in between the fourth and fifth value. Don't round up, no rounding. So yeah,
perfect.
That makes sense. It has to be like that. What the hell?
I mean, you just got it. You know, this is the point where most of the students get stressed out and they never get a right answer. And they're trying to justify the answer at the end of the book. We don't have to do that. We have to follow a method, and it is keyword, estimate. Estimate means estimate.
Yeah.
Not calculating 0.25. No, we are estimating. You get my point? First, values are round up. I mean, do you understand? These values are rounded centimeter values. So we are working with the data which is so rounded up. I mean,
estimate. Yeah.
You're estimating.
So why are you trying to? Yeah. Because in school they don't start with that.
Yeah.
They make it look like the value we're trying to find, it is that value. It's the accurate value, which it's not. It's an estimate, which he doesn't start with, which makes it a little bit confusing.
Okay.
Yeah.
So that's a good place to end this particular session. But we'll continue with our next session. Are you ready to continue now, or take a break of 5 minutes and then we'll continue?
We can do it now. I'm ready.
So let's continue. Okay. So the other example is about continuous data, as I was talking about. So we'll say, what happens when we have a continuous data to work with? So let me enlarge this a bit. so that it becomes easier for you to visualize.
Mhm.
Okay. So we'll actually calculate the similar values which we did last time, but now the data is continuous. Continuous means uh, we have uh, running, like if you measure the height of students in the class, you get my point. So the height could be 170, 171, 172, 173, something like this in
Oh,
centimeters, 172.5. I mean, there are a lot of values which are kind of considered to
right.
be
Yeah.
continuous. Now, if I give you that kind of data to work with, how do we find medians and quartiles? That is what we need to understand. So first thing is, when you have the data, arrange them in a particular order. Then group them into classes, right? So those are the steps which you need to do. So let me just write these here. First is arrange in increasing order. Right. And second step is divide into classes. We normally use the word interval. So depending on how much data is there, you can decide the length of the interval, right? So in this particular case, it is very similar to the example which we took. And here also, can you
Mhm.
please read this question here?
Yeah. The table shows length of Atlantic salmon caught by Amy.
Yes.
Great. I love to be a
Sure.
fisherman.
So
Right.
what I did was we just grouped them into different groups. Most of the salmon, when we had looked at the data, the minimum value was close to 60 and the maximum was close to 75. So that becomes our total range. Now we divide this range into intervals of 2.5. So to be very precise, so we have an interval of 2.5 here. So 60 to 62.5, 62.5 to 65, 65 to 67.5, and so on. So I've just not used inequality in this particular case, but I'm saying that my interval is from 60 to 62.5, correct? Now here, I will discuss with you two ambiguities which are defined, which are seen in many books and which are not clear. So what I've done is I'm
Mm.
starting with an ambiguity. I'm just not saying whether my values include 60 or exclude 60. I'm not saying whether
Yeah.
my value includes 62.5 or exclude 62.5 in the very first interval 60 to 62.5. So you have to
Mm.
understand. So what normally happens is that when we have an interval like this, then if let us say this length of the fish is 62.5, then we'll consider it here, not there. Do you understand? That means we will treat this interval in this fashion. That is, interval 60 to 62.5 literally means that the length here is greater than equal to 60, but less than 62.5. Is that clear to you?
How
Yes.
do you know that though?
No, this is how I have defined. When I collected my data, if the fish length was 62.5, I made a count here,
Oh,
not there.
okay. Yeah.
You know. Now, so you have to be very clear whether this is what you're going to follow, or sometimes we do this also. We say this, but we say, well, 62.5 is actually included here.
Yeah.
So either
Yeah.
one.
So
So or. But or means you should be sure about it before you start answering the question. You get my point.
oh right. Okay. Yeah.
If you are given
So
the values in the interval form, there is no ambiguity. You're clear about it. Whether you're working with this kind
yeah.
of data or that kind of data. You understand?
But just a quick thing. So if they gave it like the way you've given it here, but they
Yes.
haven't specified what's included or what's not included, then how do I know like do I just make up saying at the end of each one, we're saying, so then on the first block, we're going to say the 62 is not included, second one
Yes.
it is included,
Correct. So
or like, do
you
you
have
just make up the rule?
in that case, you have to decide whether you follow this or that. Therefore, it means
Yeah.
again what? It means check with your teacher. Because actually, the teacher is
All right.
deciding for you, not you. Your teacher is deciding for you. Check with your teacher.
I don't like this.
Hmm?
The reason I chose maths was because so there's only one answer. There's no discussion. It's like no debate, no analysis. I don't
Not
like
in
what's happening.
statistics. Not in statistics. Here, a lot of ambiguities. Again, they take help of the word estimate
Oh,
and approximate. It is all approximate and estimate. Okay, so it doesn't matter whether you include or don't include. It doesn't matter much.
yeah, no. It's just that there is still, at the end of the day, even though it's an estimate, there is only one answer in the
Correct.
mark scheme. So
Correct.
you have to follow your teacher's method or whatever it is. Oh,
Perfect. That is
okay.
why before even starting to teach you, I'm telling you the boundaries is that is very important, right? Because
Oh,
these are different
right.
boundaries in different countries, and I don't know exactly what your teacher is going to follow. Your teacher is correct from my side, so I'm just giving you an option. Check with your teacher which is the correct way, and
Okay.
follow that. Is
Right.
that clear to you? Okay, now great.
Yeah.
So before we begin with this, you should be clear. If I write 60 to 62.5, again 62.5 to
Mm,
65, what does it mean? 62.5 is
right.
included or not included in first data, right? Now, I've seen some
Yeah.
very beautiful solutions and some excellent books. What they do is, if they're rounding the figure to one decimal place, they will make a group not 60 to 62.5, but they'll change this number to 62.55. So in that case, there won't be any data whose length will be 62.55. Do you get my point? And this also they will write
Yeah.
62.55. You understand now? So they will use two decimal places if the data is given to one decimal place. So that actually removes the ambiguity. Let us say, you get my point.
I get it, but
Yeah.
then I kind of lost it because then the same values are still there, but
Yeah.
I know it doesn't apply anymore because the rest of the data is in one decimal
Let
place.
us say your data is like this: fish length 61, 62.5, 63, 64.2. Let us say this is your data.
Yeah.
I am using an interval which is 62.55, another decimal place. There is no data to second decimal place. So now I'm very clear. There is nothing which is 62.55, right? That is
Right.
how we make
Yeah.
this continuous, right? To make it continuous, we have to repeat it.
Oh.
Otherwise, there'll be a break.
All right. Okay. Yeah.
You get my point?
It's
So
clear.
if I use
Yeah.
62.55 at both the places, my data is absolutely clear. It is up to one decimal place. So there won't be any number which will be 62.55. It will be either less or greater.
Oh, so if you were going to say where does 62.5 lie, it has to be in the first block because
Yes,
you ended it with the 62.55 and it can't be
correct.
in the next one.
Next one. I will use that
Oh,
in the first block.
get it.
You get the idea. And
Yeah.
I will
So
make a
if,
group. I will make a group which will where I will
mm,
write 62.55. I will go to two decimal places if the data includes one decimal place. Correct?
oh,
Is that
okay,
correct?
yeah.
Yeah.
So if the data all had second 2 DP, then
Yes.
if it had like this, you would make the next one to 3 DP like that.
Yes. Yes. Now, why did
Okay.
I take one decimal place? Because I rounded all values to 1 centimeter. So I do not have any decimal place in my data. You get my point.
Mhm.
So in my
Yeah.
examples, I'm taking length of the fish round to centimeter. Therefore, I do not have any decimal value. You know point. So that is what I normally assume.
Mm,
And therefore, I've taken a length which is 62.5 and I will not have any ambiguity. You get the idea?
right. Yeah.
Okay. But remember, we have rounded the data. Actual length of that will appear, right? The fish
Mhm.
length could have been 62.5, but we rounded to 63.
Right. Okay. Yeah.
And then we made our table. Think like this. But anyway, two very important things to consider is whenever you work with such groups, you need to understand whether you are following this nomenclature or that nomenclature. In case you get a
But
data.
does that still apply? Does that still need to apply if we just put 62.55?
No, then not. Because
Yeah.
the
Okay.
the data is accurate to one decimal place, you have used two decimal places.
Right.
then it will never apply. Correct. Now,
So can I just do it like that then?
yes, you can. And then
Okay.
round your answers to required value. So they'll say round
Okay.
your answer to one decimal place, round your answer to one decimal place. You'll get accurate results.
Okay. Yeah.
You have to be careful on
I'll
this.
do that.
Again, check with your teacher. What is the best? Because I don't want you to waste your time in things which are not very critical, right? So rounding and working with more decimal place means extra time. We don't have luxury of time in test paper. So you have to
Yeah.
clear all these
Okay.
points before the test. Okay.
Right.
Perfect. I'd like you to read these points. Can you please read this? What have I written here?
Describe cumulative frequency plot.
Ojai. Now,
Okay.
cumulative frequency
Oh,
plot
good.
is given many different names. Let me just explore this part also. It is called Ojai.
All right.
We say cumulative frequency plot, cumulative frequency polygon, cumulative frequency diagram, cumulative frequency curve. There are so many terms which are used with this cumulative frequency. The idea here is whenever you make this plot increasing order, it is in the S shape. So sometimes we also say S-shaped graph. Now, it is strictly speaking a polygon. The actual name should have been cumulative frequency polygon, because when we have this interval, then all the elements, now let's look into the data and then I'll get back into this discussion of the name itself.
Oh,
Okay.
okay.
So the data given to us is that in the first interval, we have got 2, the second 8, and likewise, as you can see. Now, this number within that interval is called the frequency. Now, cumulative frequency is the running total of your frequency. That is cumulative, right? Add on. Is that okay? So that is the meaning of
Yeah.
cumulative frequency. So what we need to do basically is that we are saying how many are below 62.5. That is what we are trying to say, correct? So that we
Mm.
say, note, default method to plot cumulative frequency diagram is less than method, less than. So we're saying how many are less than 62.5? There are 2 less than 62.5. This is what we are trying to say, cumulative frequency. Is that clear?
Yeah.
How many are less than 65? Well, 2 and 8. 10.
10.
So you keep on
Mm.
adding. So what method we are applying here is, which we call the
Less
default
than.
method, is we want to plot cumulative frequency diagram where the method is less than method. Whenever you're applying less than method, the key value you look at is the upper bound. Means what is less than 65? The
Mm.
upper bound of the interval. You get the idea.
Yeah.
Very important to
It's
understand.
clear.
There is another method also, which could be there in the test. They may say, draw the cumulative frequency diagram using more than method. You get my point? Then in that case, how many are above 660? All of them.
Yeah.
It will be reverse. That graph will be
Okay.
dropping down. So one point, read
Yeah.
your question carefully, because in GCSE they do.
Yeah. So if it says less than method, you use the upper bound. If it says more than method, you use the lower bound. And then the
Default
graph
is
would
less
invert
than.
the other way.
Default is less than, you get a S-shaped increasing
Oh,
curve.
okay.
Okay. So, and it has a different
Yeah.
name, Ojai also. Many students will use this in different parts of the world. Then draw the cumulative frequency diagram. That's what we are going to do. From the diagram, we are going to estimate the median length of fish, estimate lower and upper quartile, and we'll find the interquartile range and 90th percentile, and we do all those calculations. Perfect. So let's begin with the
Yeah.
cumulative frequency graph. I will say a polynomial. Well, good. I have mentioned all the names here. So describe ogive or cumulative frequency polygon, diagram, graph, or S-curve. These are alternate names which are being used in different places. Okay. We will follow the method, the name polygon. Polygon means it is a set of lines. You understand? Not strictly, because polygon could be closed, open, whatever, but it is definitely not a curve. When we do 60 to 65, let us say if we get these data elements, then I'm going to join them with a straight line, not with a curved line. You get my point? My
Oh, okay.
frequency diagram will be a straight line, not a curved line. Reason is,
Oh,
yes, let's understand the reason. Why it is not a curved line. It is a straight line in between the two intervals, because when I say there are two elements in between 60 to 62.5, where are those two elements? They are in between them, correct? We are
yeah,
saying there are 15 elements between 65 and 67.5. We don't know what their actual values is, right? Where are they?
yeah.
Let us say this is my group, which is 65 to 67.5. Where are my data elements? So what I assume is that
Somewhere on the line.
they are linearly distributed uniformly between this.
Oh, because if you drew a curve, that means you accurately know where each one of those points are, which you
Yes,
don't
yes,
know.
yes.
So you have to assume
Then you
that
can
they're
draw
all
the curve,
equal.
but we don't know.
Oh, yeah. Okay.
You
I
got the
didn't think
point,
about it
right?
like that. Now it's really clear. Yeah.
Yes, yes, yes. So now, Amy, you collected these fish, found their lengths, but you forgot. Once you put them on the table, and then the fish doesn't exist.
Wow, that was a waste of time.
Okay.
Yeah. Well,
So now, getting back to the topic, cumulative means increasing by successive addition. This is what word means. Running total. That is what it means. Plot upper class boundary with cumulative frequency. Connect points with a straight line. Lines signify linear distribution in the group. This is the most important sentence. You understand?
mm-hmm.
When I'm drawing
Okay.
the straight line, it will signify linear distribution in the group. So all 15 are actually linearly distributed between 65 and 67.5. If I say there's only one element, I'll assume it to be in the center. The value of that element will
Right.
average of 60 and 62.5. It'll be 61.25. You get my
Yeah.
point?
Yeah.
So I can now assign a value very accurately by the assumption that they are linearly distributed in the group. So
Yeah.
I can actually give you two decimal place answer here using this distribution to be linear. And then
Right.
I will round it to the required answer. This is what I'm going to do. You see how accurately we can work with the
Um,
running totals?
yeah.
Got
Yeah.
it? So
Yeah.
now let's look into this. So basically, when we have to, let's consider the points. So first is, we'll make a cumulative frequency chart that is increasing total, right? So 2
Mm-hmm.
and 2 plus 8 is 10, 8, 10 plus 15, 25. So I made a cumulative chart, and here we get the value of n, which is 80. So the total number of fish in this case were 80, and they are distributed in these intervals as shown in the diagram. So how many are less than 62.5? There are two which are less than 62.5. How many are less than 70? 58 are less than 70. That is what we are trying to say here. And how many are less than 75? 80 are less than 75. That is what we are trying to say when we say this cumulative table, this case. Is that clear to you?
Yeah. Yeah.
Now, another thing, when we have to plot this diagram, we could do a couple of things. And one of them is that we could consider all the two to be at the center point. We could do that, right?
Okay.
Yeah. So we could do that. But what we will actually do is, when we are going to plot, we, as you had discussed earlier, we are going to take the upper bound. Do you see? Because we are doing the increasing, right? Less than graph,
Yeah.
less than method.
Mm-hmm.
So we are going to use the upper bound. Is that clear? So we are saying that how many are less than 62.5? There are two less than 62.5, and therefore I get a coordinate point. 62.52.
Oh, because you took the cumulative frequency. Oh, and then you get a
Yeah.
coordinate point, right?
Yes.
Yeah.
Upper bound 62.5, cumulative frequency 2. Upper bound 65, cumulative frequency 10. I get the next coordinate point. I have to draw the cumulative frequency polygon or diagram, whatever, right? So these are the 6 set of points from the 6 intervals. Last one being at 75, I got 80. So that is my last
75.
80,
Yeah.
right?
Could I ask 2 questions?
Sure.
First question is, you know, when you draw the polygon,
Yes.
you know, where you don't like put it to the origin because it doesn't start at 0. Where do you know where to put the point? Like, is it the
At
lower
your
bound?
I'll
Is it
tell you.
60?
Good question.
Oh.
Good question. Very good. Okay. So what we do here is like this. How many are less than 60? So we'll go for less than 60. How many? 0. So when 60 becomes, so that point is 60, 0.
Yeah.
You get the origin now? Starting point? Starting point is 60, 0.
Oh.
How many are less than 60? 0.
Well, the way you did that. Yeah. Oh, right. That makes sense. I didn't understand why it was, because the cumulative frequency is 0, it has to be on the axis, and then it's at 60 because it has to, there's nothing less than 60.
Nothing less than 60. So, very important to understand, Amy. Note. Can you please read this note?
Default method to plot the cumulative frequency diagram, or like polygon. The less than method is where the upper bound is taken to plot the graph.
Clear. So all these coordinate points include the upper bound and the cumulative frequency, and that is the graph which we are going to draw. We'll take cumulative frequency on the y-axis and the upper bound values on the x-axis, and then we are going to draw this. And we are saying, when we say 80, that means everything less than 75 is 80. Okay?
Yeah.
Now let's go to how do we actually do it. Now here's your graph. Now you will notice in this graph that I have taken a point 0 for 60, because what is less than 60? What is less than 60 is nothing, and that becomes our starting point. So it is very important to consider the starting point.
Oh, right. Okay.
Is that clear to you? So we did calculate the other points, 6 of them earlier. Now coming back to your question.
I was thinking,
read.
How about less than 60? So that's weird. I didn't know you were going to have that on the next slide. Yeah, because I was just thinking that if we have all the other points, won't it just be a line floating in the middle of the graph? So I was wondering, where is that like start point? But then, when you explained it being 60, 0, it makes sense.
60, 0. That has to be your starting point. If you miss this point, you have missed at least 10% marks.
Yeah.
Very critical. And that is your last point. Is that clear to you? Which shows n value of 80 in this particular case. Now, this value of 80 is very critical. Since from this value, we are going to calculate median, Q1, Q3, and everything. Is that clear to you? 80 is our n value.
Right. Okay.
From where we'll do all the calculations. Now, in this case, where we are considering the cumulative data, in that case, we'll take n as 80. Now, let's see how to calculate the percentiles using, we have already drawn the cumulative graph. I hope, is that clear to you? This ogive or the cumulative graph is clear to you, right? So we just plotted these points on the graph and then connected them with straight lines. All are straight lines, right? No curves.
Linear distribution.
That they are linearly distributed. All these 33 elements are linearly distributed in the interval 67.5 and 70.
Right.
Okay.
Yeah.
Now, let's go to percentile definition and see how do we work with percentile and ogive or cumulative frequency polygon. Okay, so now we'll discuss cumulative frequency plot, quartiles, and percentile. Plot ogive or cumulative frequency polygon, which we have already done. You can see right there from the given data in the table. Now we'll estimate the median, lower and upper quartiles, interquartiles, and 90th percentile. Now clearly, we have the value n equals to 80. To find the median, we have to find the center value. So we'll do 50% of 80. So 80 times 0.5 is 40. So we're looking for where is 40 in the graph, correct?
Yeah.
So you can draw a value. The horizontal line, which is here, 40, correct? So you go like this to the graph and then down there, and you find the median value can be read from the graph as 68.6. So you get your median from the cumulative frequency. Is that part clear to you?
Yeah.
Correct.
I
Now,
did
lower
want to
quartile
ask something.
25th percentile. So multiply 80 by 0.25, you get the value 20. So this is your 20, right? And you go and then check the value 20, and you get Q1, which is 66.6 in this particular case. So you get the value of Q1.
Could I just ask something quickly? If you had to find the percentiles, and then you've got the table, but they haven't given a graph or anything, and you haven't graphed, is there a way of calculating without the graph?
Yes, there is.
Okay.
So I'll take that tomorrow in the next lesson.
Okay.
Without the ogive, how do we calculate? And there is, that is the place where linear distribution will be handy.
Oh, right. Okay. Yeah.
I'll give you a hint.
Yeah, back to the graph.
Give you a hint, right?
Oh.
So calculate from the table. You are saying that 60 is the value which you are looking for to find the upper. This should not be upper. If this is, upper quartile means Q3, right? Okay, Q3. So upper quartile is 75th percentile, and you're looking for a value which is 60. Now in your graph, where will 60 come? 60 will come here, right?
Yeah, because the one before is 58, right?
Which is within the from 70 to 72.5, correct? There are 19 elements in this interval from 70 to 72.5, correct? Already before this is 58, correct? Where is 58, 59, 60. So out of 19 elements, 60 is actually very close to 70. Therefore, my estimate will be 70.2. Not 70.5. My estimate will be closer to 70, and I'll estimate this as 70.2. You get the idea?
All right.
There are 20 elements. I'll say 20 elements. Each is like, I can distribute them now linearly between 70 to 72.5. And this is very close to 70. So my estimate is 70.2. Do you see how far?
All right. Okay. Yeah.
Because of my linear distribution. Similarly, you should be in a position to reason out for the 20th value. 20th will means within this interval. How? From 10 to 25, right? So 10, 11, 12, 13, 14, 20 will come close to 25, right? That means closer to 7.5. And then you'd say 66.6 is a reasonable estimate. From
okay.
That is how you're going to. But of course,
makes sense.
Graph makes it very simple. Once you make the lines
and accurate.
Correct. So similarly, Q3 will be 75th percentile. Once you do Q3, you get your value. And there, sorry, this is Q3, which is, let me write this. Okay. So Q3 is 75th percentile. You get a value, which is 60 for us. So for 60,
$70.2.
Here it is. We are doing now Q3, right? Q3 is 70.2, right? Yes, 60. So on this scale, 60 is here. And then when you go to 60, you can read the value. Sorry, 60 is here. Sorry. That is 90 percentile. 60. I wrote this Q3. And the value is 70.2 on the graph.
Yeah.
And that is how you can easily read. Now you found how do you now know how do we find Q1, Q2, and Q3 from the graph. Interquartile range is difference between Q3,
Right.
Q3 and Q1. Okay. And so it is 70.2 minus 66.6, and we're just 3.6 in this particular case, right? That is interquartile
Yeah.
range. 90th percentile means I'll multiply 80 by zero point 0.9, get 72, and at 72, I've drawn a horizontal line which ends up on the axis at a point which reaches 71.8. So 90th percentile is
Right.
71.8 for me. Is that clear to you?
Yeah.
So that is how you could
That
use
was
the
clear.
cumulative frequency graph to calculate all the quartiles and or the
Wow.
percentiles. Do you understand?
It's so easy when you know how to actually do it, isn't it?
So can you summarize this part, please?
Yeah. So where do I? Oh, like you said, when we're beginning with this topic, you just first think that it is an estimate, whatever
Yes.
you're calculating. There are a few differentiations depending on where you are in different countries and stuff. But at the end of the day, the method is the same. It's just here and there will be a few tweaks. But yeah, so when talking about this table, we use a less than method.
Yes.
This is the standard kind of default method, but don't just think this is the method and end of. It's always like read the question. So
Really good.
usually you see this S kind of shape. We don't, so I just explained why we don't say curve is because the points are evenly like or linearly distributed within each interval. And so when you plot the points of those intervals, you have to draw a straight line between them because you don't know exactly what the values are in order to draw that curve.
Correct.
So always draw straight lines between the intervals. And so that's
Upper
where
bound.
oh yeah,
Upper
and
bound.
then yeah, so when you use the less than method, you use the upper bound, and then when you work out the cumulative frequency, because it's you use the upper bound and then say what's less than that, how many is less than that. So then you just start adding up the values, and then you would, by the last interval, you'll have the number of like things in that data set all below that last upper bound that you've got. So yeah, that's critical. And then when we came to this kind of question is when it's given in this kind of format, not with the inequalities, how do you know whether that upper bound is included or is it not included and things like that. So to prevent you from getting all like confused from all of this, if it's given all the data in like to 1 decimal place, then if you make that last value to 2 decimal place and make it 62.55, then none of the value in the data set would have that. So you kind of eliminate that, like you said, ambiguity between whether it's included or not.
Correct.
So yeah, that's a crucial thing. Then the next thing we learned was just about how to draw the graph and where to start. The starting point would be whatever the first interval is, that lower bound, is there anything less than that value? The answer would be no, because then it wouldn't have started from that. So then the point that you plot is simply that lower bound and then 0.0, because there is the cumulative frequency for that is 0 because there's nothing less than that. Okay. So remember, you join it up, because if you don't do that and you just have like a line floating in the middle of the graph, then it's all wrong. But then make sure the cumulative frequency is on the y-axis and then the upper bounds are on the x-axis. Labeling your axes is also important, because it looks like it's small marks, but they all add up and then you just lose a whole grade and you just be like, whoa. So yeah, let's remember that. And then the n equals 80. So the total number is critical because that's the value we're going to be using to find all the percentiles. And when it says your lower quartile, it's quite simple really. After you find your 25%, like we just learned about using the formula, when you find the term, all you do is go to your graph, draw a nice straight line, accurate line, and then go down and then read off the value and write it down.
Yes. Now, Amy, let me summarize here. One more thing I will add is sometimes we use the value of capital N, which will be n plus 1. Now, but sometimes we do that. You may have to check with your teacher on this point also, that in case we are doing cumulative graph, do we take n as n plus 1 or not? Is that clear? Should I be taking this as 80 or 81? Because median is the middle value. You understand? So 50th, if there are 80 elements, actually speaking, 40th element is not the middle value. The middle value is between 40 and 41st element. So exactly speaking. But because it is a graph which
Yeah.
is estimated, and for easier calculations, we use the even number, 80 in this case. It gives us a better values, and on the graph, easier to plot. Correct? So 80
Oh,
makes
right.
more
Okay.
sense here. If I would have changed this to 81, I would have made a lot of, I cannot plot any point which is like 72.10. Do you understand? Very
Right.
difficult for
Yeah.
me to plot. So in this particular case, taking n as 80 makes sense.
Okay. Yeah.
Good.
I think we did it like that at school as well. So
Okay,
yeah,
that's
that's
good.
all right then.
That's good.
Yeah.
Yeah. For a graph, this is a better value to consider.
All right. Okay. So
Okay, then.
yeah, that was a great lesson. Thank you so much, sir. It really made a lot of sense. Thank you for going back to the basics and like explaining it from the start really clearly. Yeah, that was really good. So thank you.
Yeah, in the next lesson, we'll take box and whisker diagrams and we'll go further into these things and then we'll close this up, right? But in case you
All
have
right.
any
Okay.
difficulties, share with me the questions. And
Yeah.
as I said, there are many questions to be answered by your teacher also. You need to discuss with your teacher about few fine points so that you don't miss any marks in the test. Okay, that's
Okay.
kind of very
Yeah.
critical. Okay, then. All the best,
Right.
Amy.
Will do. Thank you so much, sir.
Yeah.
Have a good week. Yeah.
You
See
too.
ya.
Thank you. Bye.
Bye.